Hello and welcome to this video where we will show how to do a 2D model in HEC-RAS. And at the end it will look something like this. It's a small ridge. This is about 500 meters and with a discharge of 5 to 60 cubic meters per second. But let's close this and start from scratch. We'll just close the program, and first thing we're going to do, I'm going to open HEC-RAS in 5.0.7 version. I'm going to bring it here. And of course we have to ensure that we have our computer with the US units. HEC-RAS is an American program, so we ensure that we have in our region and time formatting is American, so that we'll ensure that we don't have problems later on. So here I am in English, United States, and all the settings are appropriate for HEC-RAS. So let's close this. And also important to ensure that we are using the international system units. If we go to options, we go to unit system, ensure that we have system international, and I recommend you also to set as default. So first thing we are going to do is to give a name to our project. That we go to File, Save Project As, and let's find a folder where locate these users. And in my case, I'm gonna just save it here. I have a HEC-RAS course, here, for example, and I will save it in model. I like to keep everything in the same folder, so I will create a folder for HEC-RAS where I will store all the files that are being created. And let's give it just project 1, for example. Yeah. So now our project has a name. I want to show you the workflow that we are going to have today. This is the main HEC-RAS window. This is the model we are going to do. And maybe it looks like it has a lot of windows. Today we will only, where I explained the previous preparation, we will go to RAS Mapper to input our geometry, our terrain. Then we will go to the geometry data where we will define our geometry. In unsteady flow, we will define the boundary conditions, how much water is coming, how is it flowing out. Then in unsteady flow simulations, we will define the plan. You will understand it later better. And finally, we will come back to RAS Mapper to see our results and to visualize and export them. So it's the general overview. So let's get started. As I said, let's start in RAS Mapper. This is a feature in HEC-RAS that is developing a lot lately. So first, I will give a projection to my project. In this case, I already have downloaded a projection file from, I think I have it in data, projection, and this one. In this case, we are using HEC-RAS 89. This is something you can download projection.pgr, and that you can find it easy. So we said OK. Then we have a projection in our window. Now we will add the terrain. For that, I would right-click on Terrain and select Create a new raster terrain. This window shows up, and I'm going to look for my raster. I have it in Data, Raster, and we are going to use the river NES. I like to keep that. We can just keep it as defaults, and yeah, we can also change the name of our terrain in case later we want to create another one with a different geometry. In this case, I will just leave it like this. A practical example, we don't focus on this. And now it's ready to create. Now it takes a little bit of time, of course. The bigger the raster, the bigger the time it will take. And finally, this is our river we will use today. I will not use the entire ridge to ensure that we model it fast and then we don't have to wait several hours. I will use this part here. But now that I have brought my terrain, I can go to my geometry window. So we close RAS Mapper and go to the geometry window. And here we can see my DM. And for that, what we will use is the 2D flow area, the boundary condition lines, and the breaking lines. By default, HEC-RAS will create a square structure, and we will use the breaking lines to break these structures in the points where we have particularities in our model. This is just a practical example. It's more complicated than I really recommend you to know what are these special points in your DM that you need to modelize better. So let's zoom in to this area where I will draw my geometry. So let's click on 2D flow area first, and then just select a small ridge here. Yeah, we just go clicking, and double click to end bracket. Then let's just give it a name to the flow area. Good. This is our 2D flow area. Now the next step, we can just do a breaking line, and I can show you how this will change the geometry later. You will understand it better visually, and we can name it break line 1. And now we can create the mesh. Now we have given the boundary. Now we will tell HEC-RAS to actually create the points for computations. Here we will have the default Manning value. The Manning value, we could introduce it as an input in the RAS mapper editor. I can show you later how to do that. But in case we haven't introduced any Manning value from a setup shapefile distribution, HEC-RAS will use this default here to calculate. In this case, we will just use 0.03. And now I'm going to generate computational points. In this case, I will of course use a very coarse mesh. I think this reaches like 80 meters wide, so 3.3 will give quite fair results for this exercise. This is good, and then I will just select enforce selected break lines, so those will break my structure. You will see it better when we zoom in. Select all, okay. And now we can force my mesh computation, and okay. Now we can zoom and see what happened. HEC-RAS has created our mesh, and we can see this break line broke the structure. Too much. And let's see. We could also change the size. We have selected that we wanted a size of 3.3 meters. What if we wanted also to change the size of the mesh that we have around our breaking line? We can go to GIS tools, break lines, cell spacing table. And here I can select how big, by introducing a minimum or a maximum, I want to be the cells around my breaking line. So these are other features for you to know. We could of course also go to GIS breaking lines, and in coordinate table there is also the options to import lines from other shapefiles. Imagine you already have lines that tells you where you have a particular area. You could use this import tool to have them in your geometry. And now I will do the last step that we will do in geometry window, that is defining where our boundary condition line. Then I click in boundary condition lines here, and we will draw it very close to our 2D line. In this case, the flow is coming from up, down, it's flowing in north, south, let's say. So let's click in boundary conditions and draw my upstream boundary conditions. Double click, and I call it upstream. Good. We can see that it has appeared with the red and black dots. That means it's good, it has created the connection fine. And now I will delete create the boundary condition downstream. Again, we draw very close to the 2D flow area, but not inside, in the outside part. Click, and we call it downstream. And it was created fine. I will save my geometry file, save geometry data as, and I will just call it geometry 1. Good. Now we have a geometry. I think I'm not forgetting anything here. So we can, let's close geometry. We can see here we have a geometry file that has been created fine. Next step is going to the unsteady flow data, this man under the wave. And we can see our boundary conditions appear in this file. In the upstream boundary conditions, we will define we can see here different options, that is selecting a normal depth, a state hydrograph, a flow hydrograph, or a rating curve. In this case, we will select the flow hydrograph. That we will define a flow hydrograph going from, let's say, 10 cubic meters to 60 cubic meters. It's a okay flow in this area. We can interpolate missing values. We can also change here the time how it's defined, our hydrograph, in which interval. In this case, hour is enough. And also we will introduce a slope for distributing flow as just 0.01. In the downstream boundary conditions, we will define a normal depth. And again, I will just set this at default as 0.01. We could also measure and do it more appropriate, but for this example, let's just leave it like this. And then I have introduced what values I want in my boundary conditions. So I will go to File, Save and Steady Flow Data as, and Flow 1, for example. And we can close and steady flow. In case we want to run our model with some other initial condition, we have these options here, initial conditions, in which we could use a restart file. So maybe you have run a model before and you want to start from the last moment of the other simulation, we could introduce that in this setup. But let's close here. We can see we have our project name, the geometry file, and the flow. So let's go right away to define our plan. This man running uphill. I will not go into a lot of detail, but we will just select all of this geometry processor and steady flow simulation. We don't have segments in this case, the processor and the float map. The starting date is gonna be just, let's select today, okay. End up date today, I don't need a particular day in the simulation. And the starting time is go from 0, 0, 0, 0 without double dots or anything. This is the format that HEC-RAS utilizes, and let's run it for 2 hours, 0, 0. Here we can introduce a description of the plan we are running, and we can call it, for example, first exercise. Just a try of what we are doing. And let's focus now on the computational settings. For the output, how I want my output, I will just choose in this case 5 minutes. 5 minutes and 5 minutes, so we have quite a few frames. And in the computational interval, this is more important. I will select in this case a starting value of 1 second. But I will tell HEC-RAS that I want to adjust time step based on current. Therefore, I have clicked on these 3 dots here, and the HEC-RAS and steady computation options and tolerance appear. I want it to adapt the time based on current, so it doesn't give me errors. The time for computing is adapted to ensure the stability of the model. We can just give us these values for flex. These values are that the current number will have a maximum of 3 and a minimum of 0.5, and this flexibility to calculate. So I think I have all the settings in my file. Again, I can save plan as, let's say, plan 01. And I also like to call it something that is representative of the model. And in this case, we can say Q from 10 to 60. And yeah, we'll just copy paste this and give the same ID. Okay, and let's compute. We have an error to the flow area, mesh to the flow area was not created successfully. This is a classical error, and I will just go to my geometry window again, and I will just force mesh recomputation. And I think that was good. Let's try once more, and hopefully this error disappears. Compute. And that was fine. Sometimes, yeah, you have this error with the mesh, but you can go to force mesh recomputations and it will get solved. And now it's computing. It's actually going quite fast. Oh, I didn't create. No, let's stop it. I forgot to click on float plane mapping. File, save plan, and compute once more. I think it's gonna go quite fast anyway, so we will not have to wait a lot. But while this is computing, and before we have the results, we can have a look at RAS mapper. I told you before that we could introduce many numbers here. How can we do this? If we select map layers and right click on it, we can add new mannings in layer. That will allow us to bring a shapefile in which we can define a different manning value depending on the polygon. This is really useful. And I really recommend you to use this if you have a manning distribution file. What else can we do? If we look at the geometry, 2D flow areas, we can define more break lines. We can also use the refinement regions to select areas in which we want our mesh to be finer. For example, refinement regions allow us to maybe select this area and have a mesh size of 1 meter instead of 3 that we are using. And I think that was roughly it. Computational points, it has more other settings, but I think that's it. Let's see how our model is doing, and it is done computing, so we can just close this window. Let's come back to RAS Mapper, where we can see the results. So we could count results. There was some problem with the computation. I cannot see them. Let's close and reopen again. Yeah, yes, maybe it was just. We got some problem with the computation for some reason. Ah, yes, I cannot see it because I am in time 0. And there is no water yet, but as I go passing, the water starts showing up. These are the results. So we can see that our river is being filled up. Right now we are looking at the depth. By default, HEC-RAS gives us this display between 0 and 15. That, for example, in our case, is too big. If we want to change these colors, for example, in the depth map, let's select depth. It will appear in pink. We will double-click in the color. And here we have the layer properties. We can edit the surface and select a maximum value of 3, for example. We will create and apply. And now we can see a more relevant coloring of our layer. Another interesting feature is if we select here up the particle tracing, and we can see how particles will move in our river, and it's really nice to see the flow development. By default, HEC-RAS will show the depth, the velocity, and the water surface elevation. Let's have a look at the velocity, for example. Again, we can move on in time a little bit. The same thing, the colors are not really relevant in this case, but we can edit and select a maximum of 2, for example, create and apply. And this is more representative of our velocity distribution. We can see high velocities here and lowers here. We can add more maps by right-clicking on My Plan and Manage Results Map Layers. This window up here. And let's have a look at Manage Result Maps. Because here I can add more maps and also save the ones I already have. By default, the rasters containing the depth, the velocity, and the water surface elevation will not be created. But for example, let's say I want to save my depth map. Then I will go to Edit Map. This window shows up, and I have my depth. And I want to save the maximum depth. For example, I could also select a profile in a specific time, but I just take maximum in this case. And also important, store as raster based on terrain and save map. And also compute, update, store maps. And now we can see if we go to the folder where we are working. This is the folder that I selected for HEC-RAS. This is the plan that I just ran. And if I open it, we can see that the depth raster has been created. So this is how we storage maps and we save them from HEC-RAS results. We could also add new maps. I also like to work, for example, inundation boundary is just a shapefile. Let's add the map so you can see it. It's just a map. Oh, it was not created. Let's compute update. You can also compute them from here. It was giving me some results. For some reason, I have an error here. Let's see, manage result map layer. Maybe I can add new map, and I can inundation boundary. Let's select the last times step, add map, and I have that value 2, compute update the storage maps. And yeah, I think I have it here for time 0, and it was the same problem. There is still no water, but in this case, we can see now our boundaries, the areas that are wetted. And I think that's it. We have created our maps. We can look at the result, our depth. We know how to storage them. So if you wanted to bring them to ArcMap or QGIS, you could do that. Also, you can add a web imagery layer. We can select, let's say, I don't know, Google Satellite, for example, and OK. This can give a nice background map to see where we are, and also nice to display it or present our results. So I think that's it. Further recommendation is give a good name plan, because your results are stored in this automatically in this folder with this name. So it's easier when you run a lot of simulations if you have a clear name of what you have been simulating. Also useful to the plan description, because the further you work on something, the more difficult it is to come back. And that's it. Thank you for the attention, and I hope it's useful for you.